Bright Tuty. Every student matters.
So the first question here is, consider the numbers 4 raised to power n, where n is natural number. Now we need to check whether there is any value of n for which 4 raised to power n ends with the digit 0. Now even if n is 250, 300, even in that case, what is 4 raised to power n? If I want to prime factorize it, I can factorize it like this, 2 into 2 raised to power n, right? Or I can write it as 2 raised to power 2n. What is the meaning of 2 raised to power 2n? That I have written 2 into 2 into 2 into 2 and so on 2n times, right? How do you think about 2 cube? You write 2 into 2 into 2 3 times, right? 2 raised to power 20 is 2 into 2 into 2. This product goes on 20 times. Similarly, 2 raised to power 2n is 2 into 2 into 2 and so on up to 2n times, right? Now in this product, in this prime factorization, all we have are 2's, right? We do not have a 5, and without pair of 5 and 2 we cannot form a 0 in the end. And it wants us to tell whether for any value of n in 4 raised to power n, it can end with digit 0. No. For any value of n, it will not produce 0, right? It will not produce 0 for any value of n. 4 raised to power n has got only 2's in it, and without it 5 present, we cannot form a 0, okay? So, and the reason is that 5 is not present in the prime factorization of 4 raised to power n, so 0 cannot be formed, okay? Find the LCM and HCF of 6 and 20 by prime factorization method. Now 6 can be factorized into its prime factors like this, 2 into 3. 20 can be factorized into its prime factors, 2 into 2, 4 into 5, 20, right? So this is the prime factorization of 20, and if you club the powers, or if you write it in compact form, you can write it as 2 square into 5. Now if I have to talk about LCM, what is LCM? It is lowest common multiple, right? So LCM is a multiple of these numbers 6 and 20, right? So we will consider the higher powers of primes. If you talk about what are the common primes here, 2 raised to power 2, right? So we will consider the higher power, 2 square, okay? 3 power 1, and in this 3 is not present, so 3 raised to power 0 is there. Hence we can say we will consider only 3, and from here we will consider 5, right? So what are the prime factors? 2 is present in 6, 2 square is present in 20, 3 is present in 6, 3 is not present in 20, or we can say 3 raised to power 0 is present, right? And in case of 20, 5 is present, here 5 raised to power 0 is present. 1 can be written as 5 raised to power 0, or you can say that 5 is not present here. Now we will select higher powers of primes. So out of these two, which is the highest power? 2 raised to power 2, so I have selected that. Out of these two, higher power is 3 raised to power 1, so it got selected. And out of these two, 5 raised to power 1 got selected for LCM, right? So this is the LCM, and what is this number? 3 into 5 is 15, 15 into 4, 60, right? So 60 is the LCM of 6 and 20. And what is the HCF? Highest common factor. So it should be common to both, right? This is the factor should be common to both, and it should be the highest factor. So out of these we will select lower powers of primes, right? So you have to keep this in mind that in LCM, lowest common multiple, we select higher powers of primes, and in highest common factor, that is HCF, we select lower powers of prime, because this is a factor, right? It should be present in both. Now highest common factor will be lowest power of prime 2, and 3 is not present here, so 3 raised to power 0 will get selected, right, which is 1. So it has got no meaning here. If I multiply it by 1, it will still be 2, and from these two, 5 raised to power 0 will get selected. Even if I multiply it by 5 raised to power 0, it will still be 2. So the HCF is 2, right, and LCM is 60. And how do I write this? LCM of 6, 20 is 60. HCF of 6, 20 is 2. So this is your answer, right? Okay. Find the HCF of 96 and 404 by the prime factorization method. So again, we will factorize these numbers into their prime factors like this. 96 can be factorized into its prime factors like this. If you divide it by 2, you will get 48. How do you prime factorize a number? 96 can be divided by 2, right? And the quotient that you will get is 48. Then you will divide 48 again, right? And you will get 24. Then you will divide it again. So you do it like this, right? You can keep on dividing like this. Right? So what are these factors? You have got powers of 2 like this, 1, 2, 3, 4, 5, 2 raised to power 5 into 3, right? So after a time you won't have to do this calculation here. You can directly see that it is 32 into 3, right? Till that time you keep on factorizing a number by dividing it, okay? So this prime factorization of 96 is 2 raised to power 5 into 3 and 404. You see an obvious factor here, which is 4. So if you divide it by 4, you will get 101 here, right? Now is it divisible by 3? No, because 1 plus 1 is 2. So you check it for some prime numbers up to 10, right? Why 10? Because 101 nearest perfect square is 100, right? If you take the square root of 100, you will get 10, right? So you just check for the prime numbers which are smaller than 10, okay? You can keep this in mind, that how do I check whether this number is a prime number or not? You just check which is the nearest perfect square to that number. In this case, 101, nearest perfect square is 100. If you take the square root, it is 10. So below 10, you have got primes as 2, 3, 5 and 7. You just divide this number by these. If it is divisible by these, then we can say it is not prime. If this is not divisible by these numbers, then we can say this is a prime number, and yes, it is not divisible by any of these. So it is a prime number. So now this is the prime factorization here, right? Now if I want to find HCF, this can be written as 2 square into 101, highest common factor. So we will go for the lower powers of primes. 2, 2 and lower power is 2. So 2 raised to power 2, right? 3 is not present here, 101 is not present here. So the HCF is 2 square, right? And LCM is equal to, we will consider the higher powers. 2 raised to power 5 will be considered, 3 will be considered, 101 will be considered. So this is the LCM, right? Now you can multiply and write it in a single number form, okay? So this is nothing but 96 and this is 101, right? So if you multiply it by 101, you can write it as 9696. So this is the LCM. Other way to find LCM is that when you multiply two numbers, 96 into 404, it will be equal to its LCM of both these numbers into their HCF. Why? Because we saw here that this smaller power here, this got selected in HCF and rest of the factors got selected in the LCM. If you take their product, it will be equivalent to saying the product of these two numbers. So the product of numbers is equal to the product of their LCM and HCF. Now if you have found HCF here, what you could have done is you could have multiplied these two numbers, 96 into 404, and divided it by their HCF for finding LCM. What was the HCF? 2 raised to power 2. Even now you will get the same answer. Okay. So up to now, let us recap the concept that we have learned. One, in HCF, we will take lower powers of common primes, which are common to both, right? Okay. And for the other, if it is not common, we will not consider it, or we will consider 0th power, 3 raised to power 0. Okay. For LCM, we will take higher powers. Okay. So this is LCM, and if there are two numbers, let's say A and B, if you multiply those numbers A and B, it will be equal to LCM of those numbers into HCF of those numbers, right? Next thing that we learnt here was that if you want to produce 0 in the end for 0 in the end of a number, we require a pair of 2 and 5 in its factors, right? So if there is one pair of 2 and 5, it will give you 1 0 in the end. If there are two pairs, it will give you 2 zeros in the end. But there should be a pair, right? We have learnt that if you even have more than 1 2's and still there is one pair of 2 and 5, in this case also there will only be 1 0 in the end, right? Until and unless you have another 5, now you will have 2 zeros in the end. Okay. So this is how it works. And to check whether a number is prime or not, let's write it here. To check whether a number is prime or not, what was the algorithm? We will go for the nearest perfect square of that number. Let us say we are checking for 101. So what is the nearest perfect square? It is 100, right? We will take its square root. What is its square root? 10. We will divide this number by all the primes below 10. What are the primes below 10? 2, 3, 5 and 7. If this number is divisible by any of these, then it will not be prime. If this number is not divisible by any of these, we can say with certainty that this number is not prime. Okay. If this is not divisible by any of these, we can say that this number is prime, right? So these are the concepts that we have learned so far. Now let's move on to the next question here, which is find the HCF and LCM of 6, 72 and 120. So what are the factors of 6? 2 and 3. 72 can be factorized like 2, 4, 8. 2 into 2 into 2 and 3 into 3, right? 72 is 8 into 9, right? 8 is 2 into 2 into 2, 9 is 3 into 3. That is how I factorized it. 120 can be factorized like 2 into 2 into 2 will give you 8, 1, 5. Now 15 is left, so 3 into 5. So this is the prime factorization of all three numbers. Now I have to find HCF and LCM. So for HCF, highest common factor, I'll consider the lower powers of prime. So what is the lowest power of 2? It is 1, right? So because 6 can be written as 2 into 3, 72 can be written as 2 cube into 3 square, and 120 can be written as 2 cube into 3 into 5. Now out of these three, which one is the lowest power of 2? It is this, right? So I have considered this here. Now I'll look at next prime, 3. So where do we get the lowest power? Here and here, 3 raised to power 1. So I'll take 3. Now I do not have any other prime here, right? So there won't be any other common prime in all three numbers. So this is the HCF, which is 6. Now for LCM, I'll consider the highest powers. So what is the highest power of 2? 2 cubed. What is the highest power of 3? 3 square. What is the highest power of 5? It is 1, right? So this is the number which will give me LCM of these three numbers, which is 9 into 8, 72. 72 into 5 is 360, right? So 360 is the LCM for these three numbers and HCF is 6. Now you should appreciate one more thing, that if you have got three numbers, the same logic that HCF into LCM is equal to product of the numbers, it won't work in case of three numbers. You can verify it here also, because if you multiply this HCF into this LCM, it won't be equal to 6 into 72 into 120, right? Because this here is nothing but 6 into 3 into 120 and this 6 into 72 into 120. So these are not equal, okay? HCF into LCM is equal to the product of two numbers, works in case of two numbers, but it doesn't work in case of three numbers, right?